Okay, this is seriously and truly the final video for Math Intense Review. My voice is not great today. This should be a fairly short video anyway. This is just for TEAS, so you should not have this video in front of you if you're doing HESI. And this is essentially the geometry section. So this video will review just geometry and what you learned in geometry. So at the top of this page, I wrote a list of the things that you are going to see in this class. So essentially this list that I wrote at the top, you can pause the video to write the list, is these are the things that you need to have under your belt essentially for geometry. So rectangles, we do areas on rectangles. We do them forward and backward, meaning you need to be able to take a length and a width and make that into an area. And then you need to be able to take an area and a length or a width and find that other missing side that's the length or the width. Irregular rectangles are the ones that look like that. You'll need to know how to do areas primarily for those, although they could ask you to do a perimeter. Both of those question types are rare. A lot of you, actually, I should mention, a lot of you never did geometry with me because it's a small section, it's a complicated section, and geometry is one of the classes that I cut often because I look at how much time and effort are you going to have to put in and what are you going to get for the time and effort. Tons of time and effort go into geometry. There's a maximum of 3 possible points. So if you didn't do geometry before and you're still not doing it, so if you're doing a secondary plan and we did not add geometry back in, you don't necessarily have to do this supplement. So if you are choosing to leave those few possible maybe points on the table, it may not be worth the complication of this class. And then the other side of the list, going back to where I was before that, circles, you need to be able to find the circumference, which is essentially the perimeter for a circle, and the area. Can't make it stop doing that. So just write circumference / perimeter. I just can't write it because of that page thing that's there. And then half circles, same thing. Distance around, because it's not actually a perfect circumference that we do with a half circle. So distance around, and then space inside. That's the way they would word those 2 questions. And then Pythagorean theorem, which is where you have a right triangle, you know what 2 of the 3 sides are, and you need to find the third. This class is review. So if you've never done geometry, this class is not probably going to be ample to really teach you how to do these strategies, because it's going to be fast-paced and it's going to assume that you've seen my strategies previously. So again, you could be doing this class for multiple reasons. One reason could be that you're really good at math, and we're just trying to make sure you have a good strategy for everything. If you're in that boat, this class will hopefully cover geometry well enough, although geometry is the thing you're most likely to have weakness in because it's not in the normal prerequisite track for what you're doing. So if you are one of the advanced people who's really good at math and any of this is tripping you up and I don't have enough explanation in here, you might want to do the geometry class to make sure you've really zoned into the strategies. If you're taking this class because you're testing again, then the score that you're shooting for has dictated what your first plan said and whether geometry was included in your first plan, and then what your second plan said and whether we added geometry in the second plan. If we didn't put geometry in when we made a second plan, you can choose to do this video or not. If you do this video, you may feel like you need more information. And again, that's up to you whether to pursue that other geometry class, whether to pursue this, or whether to pursue neither of them. If you are shooting for a really high score, and a lot of you that retake the test, it's because you're trying to get almost perfect. You will want this, and if you are not 100% clear after this, you will want to go back to the geometry class itself if you haven't taken it. Many of you who are shooting for that high, it's going to be something that you've already had in your, probably in your original plan. So this first page is just a regular perimeter and area when they give you the sides and they have you find a perimeter and an area from the side. So this is what I'm considering a forward area. Just a quick note, squares are considered a type of rectangle, but they're obviously a specific type of rectangle that's perfectly even. If ever they give you one of these and it's a straightforward perimeter or area question and they only label one side instead of like over here where they labeled two, it's a square. So you can assume that all the other sides are 9 centimeters as well. With a rectangle like this one over here, you're going to assume that the length is the same as the length and then the width is the same as the width. When you do a perimeter, you add up the sides. There's always going to be 4 sides because it's always going to be a rectangle that you're dealing with, unless it's one of our irregulars. Then it could have any number of possible sides. So on this one, what I would do is 9 plus 9 plus 9 plus 9. Mathematically, that will achieve the same thing as doing 9 times 4. But I don't like to think of it that way because I feel like that doesn't give you a visual of what it is you're finding. It does give you a visual to say, I'm walking around this and I'm adding up the sides. So either way that you go, you end up with 36. Don't forget about units. So the unit is centimeters in this case. And it's not square units. We use a flat unit, like a flat tape measure or a flat yardstick or a flat ruler when we do a perimeter on a rectangle. You can use a one-dimensional measurement device. So it's to the power of 1. And when something's to the power of 1, we don't specify its power. Area, you're going to do length times width equals area. So in this case, that's going to be 9 times 9. That's going to give us 81, and it's going to be square centimeters, or the other way they can do that is centimeters with a subscript that says squared. So 81 square centimeters or 81 centimeters squared. I'm going to skip the one that's in the middle there because it's another square. I'm going to do this one because it's an actual rectangle. So on perimeter for this one, I'm going to do 15 plus 5 plus 15 plus 5. Again, it's up to your own style. Some people do 15 and 15, and then they do 5 and 5. To me, it's always made sense to act like I'm walking around it. So I started there and I went 15, then I went 5, then I went 15, then I went 5. So if I do this, I'm going to have 40 total. And then again, it's just going to be the unit. So in this case, it's again centimeters. They'll give you a unit name if they want you to have one. If they don't give you one, you're just going to use units as a generic. Area, we're going to do length times width. This time that's going to be 15 times 5, which is 75 square centimeters. Remember that the reason we do square centimeters is if you're trying to measure the area of something, the space inside something, you would need a 3-dimensional or actually 2-dimensional measurement device. So an area is like measuring the carpet in a room, and a perimeter is like measuring the walls. So if I measure the walls of the room that I'm sitting in, all I need is a tape measure because I'm just going to do a 1-dimensional length for each wall and then add those up to get the distance around the room. With carpet, if you try to imagine measuring how much carpet is in your room with a tape measure, you'll quickly realize that won't pan out. You can't do that because you're trying to keep track of 2 different directions at the same time. So we have to use a 3-dimensional, actually 2-dimensional. I keep correcting that because volume is what's 3-dimensional. Whereas this is 2-dimensional. So it just needs, you need something that is square. You would need a square that was 1 foot by 1 foot or whatever. and you would need to set down that square and then pick it up and set it down again. You couldn't use a one-dimensional device. So these will not be answered correctly if you answer them without square units, and you know that they'll have both of them there. This one, on both perimeter and area, they would give you a 40 square centimeters option along with 40 centimeters for perimeter. So you'd have to know it's that one. They would give you 75 square centimeters, and they would give you 75 centimeters. And you would have to know that this is the one that you want for the area. That is probably the most common reason people miss on rectangles, since rectangles are relatively easy, is they don't go that final step and watch their square units. So that's all I'll do on this page. This next page is the backwards areas. If you want to label it for your information later, you can. So these are what I consider backwards, because you start at the area and then you move backward to getting the length or width. And so this one, I don't know why this one is not in my packet. That's so weird. So I will do the first couple of these, I guess. So a rectangle with a width of 10 centimeters has an area of 200 centimeters squared. What is the length of the rectangle? So remember that we used the squared thing because we measured it using a square device. So you do not square the number. You don't do anything with the squared. All this does, the fact that that's got that exponent, is it tells you that this is the area as opposed to a length or a width. So you're just going to use the numbers. If length times width equals area, and if we know that our width is 10, and we know that our area is 200, we can fill in that statement and say the length, whatever that is, times 10 will equal 200. Then we can solve for L. So saying L times 10 is like saying 10L. So then we just divide by 10, and then you have 200 divided by 10, and that's going to give you 20. And then you're going to need to answer this in centimeters, not square centimeters, because this answer is not an area. It is a length of something, width of something. You don't have to do this as like an algebraic equation. If it makes sense to you that you just take the number that's area and you just divide that by the other number that you have, you don't need to get fancy and set up a whole equation. The next one, same kind of thing. What is the width of a rectangle that has a length of 2 inches and an area of 50 square inches? So we are looking for width this time, and it 100% does not matter whether you're looking for length or width. They are the same thing. So length times 2 equaled 50 in this case. That's going to mean that that other side was 25 inches. This answer is not an area. It's a length or a width. So you're just going to say inches. So that's backwards areas. This next one, these are the irregular. I pull my math worksheets from goodness knows where, so they're usually not labeled the way I want them. So label that irregular rectangles. This will help you. Having titles will help you make sure you study everything and that you've got everything down off the top of your head. The other thing to do on this one is add area. This is a perimeter worksheet. The only reason that I use this worksheet is it's really kind of time consuming for me to draw irregular rectangles and make them work out. For whatever reason, whoever was teaching with this worksheet just wanted them to find the perimeter. That would be a huge waste of these shapes that take so long to draw. So we are going to do an area and a perimeter for every one of them. As you're filling this in, you'll remember that you're always going to have square units when you're answering an area. So you can go ahead and fill in the unit as long as you fill it in correctly, because I filled it in incorrectly on this one. So fill in the unit that they're using and go ahead and put squared, or put squared when you answer, whatever makes more sense to you. Just make sure you're very conscious of that. We're just going to do this first one up in the corner, and I'm going to leave the rest for you to practice with. You have to make 2 rectangles. That has to be your first step, is to take it from this weird shape to being 2 rectangles. The way that I did that in this case was I went like this, The other way that you could do it is you could go like this. I always, excuse me, I always picture horizontal, but always put the line where it makes sense and where it's going to be workable for you. Whenever you put another line in, you're always going to cut a certain side. So this 9 centimeters that's over here, we now need to be really careful with that 9 centimeters because we're never going to use the 9. We're never going to use the total of that side because it's cut across the 2 rectangles. What we have just done is created a rectangle here that we can do area for and perimeter and all that. And then we've created a rectangle here. So now we've got rectangles. Rectangles are easy to deal with. We just spent the last 10 minutes working with rectangles, but irregular shapes are not. Just to address a common question, if you've never thought about what I'm about to say, don't think about it now. I'm only saying this if you're thinking it. Some people like to put a line in over here and make it a bigger rectangle. You can do that, but adding things up and dealing with less overall space is always preferable. It's always easier. So if you've ever done these before and you've done them by doing this instead of doing this, that's not my recommendation. You could be accurate, especially if you're good at that, but it is much safer to keep what you have and not add anything into the space that you're dealing with. So now I need to determine what are the sides that I actually should use and what are the sides that I don't. The sides that I should use are the ones that match up with the individual rectangles we just made. So here we've got 12 centimeters. That is the entire length of our pink rectangle. So that is a length that we can use. Same thing here with the 3 centimeters. So we have the length and the width for the pink rectangle. The purple rectangle, we've got 5 right here. That is an actual length. What we don't know is this measurement, the length or the width, whatever you want to call that. We don't know what that is. There is always enough information present for you to find out what it is. What we need to do is take this 9 centimeters over here. So we know that this entire side, which I'll draw in yellow, we know that this entire side is 9 centimeters. We also know that this is 3 of those 9, and all that makes up the 9 centimeters is the length from there to there and the length from there to there. So if it's 9 and then 3 of the centimeters are in the other rectangle, that tells us for absolute sure that 6 centimeters is what goes here and here. It's always going to work that way. There's always going to be enough info for you to take one thing, subtract another, and know what you need for your side. A quick note, something I emphasize very heavily in the original class, and I recommend still going back to that if you are struggling with this. There's horizontal and there's vertical. So when you're thinking about what sides add up to what bigger side, you want to be thinking horizontal, vertical. So the things that we have that are moving horizontally in this rectangle are 12 and 5. So as an extra exercise, you could also take 12. Remember that in class, I call this the parent side. So the parent side is the one that has the full length. That's the maximum possible length for a horizontal or a vertical space. So nothing in any of this exceeds 12 centimeters lengthwise. 12 centimeters is the parent. When we decide how to figure out a missing side, we look at making sure we are going horizontal or that we are going vertical. All of your smaller horizontal sides will add up to your bigger parent horizontal side. All of your vertical sides will add up to your bigger vertical side. We already did this with the 9. So the 9 was the parent, and the other 2 lines that are vertical, there's only 2 spaces that are vertical, are 3 and 6, and that's how we get the 9. With the 12, I could find this side right here, because I can say 12 is the parent, and then the other one is 5. So I can say 12 minus 5 is 7 centimeters, and I can label this side as 7. So if I took all of my horizontal sides that are smaller and I added them up, I would say 7 centimeters and 5 centimeters is 12 centimeters, 12 being the parent side. So get good at filling in the missing sides first and foremost. Make sure you're understanding how to do that, and make sure that you are doing that really before you do anything. You should actually do it before you split up your rectangles. That's not what I did this time. So make sure that you do that. Think about horizontal and vertical to do it. I will do a fast run through when we finish this problem of the next problem and how to do the sides without ruining the problem for you. So now we need an area for each of the rectangles. I'm going to do area first, just the habit that I'm in. So for area, we have 12 and 3 up here. So if you take 12 times 3, you'll get 36 square centimeters for this rectangle. This rectangle here is 6 and 5. So if you multiply 6 times 5, you'll get 30 square centimeters. Now we're just going to combine those together to show that if you put together this amount of space and this amount of space, you're going to get 36 plus 30, or 66. So the area is 66 square centimeters, or centimeters squared. The perimeter requires every side. And again, it's usually a little bit easier if you've gotten every side filled in prior to starting to split things up, or prior to starting to do math. So we needed to have this 7 filled in and this 6. That's the only two things we need as far as perimeter, because with perimeter, let me find one more color here. Let's do red. So with perimeter, I need the distance around the entire shape. So I'm only going to do the lines that I'm coloring right now in red, because I'm only going to do the lines that go across the outside of the rectangle. So I have 12. Here I can use 9 because I need that entire side's length. So 12, 9, 5. I do have to use this 6 right here because that is an outside edge. And then I need to use that 7, and I need to use that 3. Just like with area and just like with splitting up your rectangle, you need to make sure you include everyone, but that you don't have somebody included twice. So don't use this 9 and then use this 6 here, because the 9 actually covers that. Now on the opposite side, that's not the case. Over here, this 3 is a new side. It's another part of the rectangle. It's not built into this line. This one is. So this one, it would be redundant to have 6 labeled there. You would just use the 9 that goes from there to there. Over here, this is on the other side of the rectangle, and it's obviously an exterior side, so we do factor in that length. So we want to make sure, just like with the other rectangles, that we're walking around the shape, hitting each of the sides that goes around the edge of the shape, and that gives us 12 plus 9 plus 5 plus 6 plus 7 plus 3. That includes every one of my sides and gives me the total distance around if I walked from there and I walked across each of the external edges. So we don't include anything that's internal, and we fill in anything that's external that's not already filled in. That gave me 42 centimeters. Really quickly, I will show you just a bit of how to shape out the next rectangle to help you start your work. If you don't want this hint, if you want the practice and you feel okay about doing it, you don't need to write this down or follow along with this. If you're having a little trouble splitting them up and finding sides, I'm going to give you just a bit of guidance. So on this one, I'm going to put a line here. I think that makes a lot of sense. You could also put a line here if you wanted to. And so I'm going to look at where my parent sides are. My parent sides, I'll try to color them in pink. It's hard to make a nice vertical line, so excuse the jagged vertical line. So I have this parent that covers the entire height or length. And then I have this parent here, and that happens to be one that I do not know the measurement of. I know the little sides instead. So when I think about how do I get this other parent, I need to figure out who is going vertically and who is going horizontally. So vertically we have our parent side. So let's figure out what we have that's missing vertically, and that's going to be right here. So you've got 15 millimeters, and 15 millimeters is going to cover 9 and whatever this is, and that's it. So if you look at what you have vertically, the vertical lines that you have are that one, and that one. There's no other vertical line. So 14 has nothing to do with this. 6 has nothing to do with this. 9 and whatever this side right here is add up to 15. 15 is the parent. So if you take 15 minus 9, you find out that that is 6. So 9 millimeters for one of our short sides and 6 millimeters for the other short side adds up to that parent. We're going to need to do the opposite when we look for the parent side that we're missing. So it's the same process as far as locating everything. Just going to end up adding things if you're looking for a parent, and you're going to end up subtracting if what you already have is the parent and you're looking for a smaller one. I'm not going to give you this number because I want you to get this practice, but this one we need to think about the side that we're looking for, whether we're looking for a parent or whether we're looking for a little side. For some reason, it's not letting me write. We are going to need, let's see. Well, my pen is frozen. So we're going to need the 6 millimeter, visualize with me because my pen is suddenly not working. So we're going to need the 6 millimeter side, which is the little one, and we're going to need the 14 millimeter side, which is the bigger one. And again, those are the only two that are moving horizontally. So there's 3 sides that are moving horizontally. There is the one with the 6, the one with the 14, and the one that we don't know as far as the parent. So I am not sure why my pen and mouse are not working. Let me try one other thing, but I may have to cut this recording and start again. Yeah, I don't know why my pen is not working. So unfortunately, I have lied to you once again, saying that this is part 4 and it's the last part. There's going to have to be a part 5 because I'm going to have to reset my computer to reset the pen because I have to be able to write. So immediately from here, resume with part 5, which you'll have both of them sitting there. Video 5 will finish out geometry, hopefully with a pen in my hand. So I'm cutting this video here, and you can go to 5 to continue.